Hello and welcome back. My name is Corey and you're my rubber ducks. And this is a series where we are in the process of creating Tang. That is a template language. Tang, the name. Anyway, a custom programming language from scratch using just our C++ skills and a few tools such as Flex, Bison, and most recently ICU for handling strings. And last episode, the previous episode, that's the one that we finally got ICU just started to be integrated. And I'd been holding it off. And in fact, I had to pause recording for like 5 days as I tried to figure out a problem that in the end it turned out that it was working correctly the entire time and I was just misunderstanding something. And that happens, you know? So whatever, it's a learning process. And so I'm kind of behind on videos. So, I've been getting one out every day, but I had some pre-prepared and I've burned through my savings account of videos, so to speak. So we're going to see if we can get caught up. But what is on the docket today? Well, we are going to see if we can start integrating our UnicodeString class that we've been creating that uses ICU. If we can start using that to handle strings in our programming language. And remember, we have our ComputedExpressionString class, and that has been backed by a standard string. And now we're going to have this class called UnicodeString that just is going to contain all of the functionality. And that way we're doing it that way so that our Unicode string class can have its own separate set of tests and nothing else in our programming language needs to interact with ICU. Just that one class does. And yeah, that's the goal. So, having said all of that, what we want to do then is let's just jump in. And I've said this before, there's nothing up my sleeves. I haven't prepared anything ahead of time. And in fact, that kind of scares me at times because I'm like, how's this going to go? When I say it scares me, that doesn't mean I don't know if I can do it. Rather, I just don't know how good it's going to look on the screen. But if we say git log, you'll see here that the last commit was episode 45. And of course, this is episode 46. So nothing's been done. If I say git status, I haven't changed anything since then. So, as I said, nothing up my sleeves. This is 100% live coding, and you see the good, the bad, and the ugly in all of this. On the right-hand side, we're going to make clean, and we know for sure that we're starting with a clean compile, and let's just say make test watch. There we go. And it's going to start the compilation process. Now, on the left-hand side, we are going to edit. Let's go first. We're going to edit the include for our computed expression string, and then we're also going to need to edit the source for our computed expression string, and then I bet we're also going to need to edit the include for what we just created, and that is our Unicode string and then the source for Unicode string. And I think that should get us started. On the right hand side, we see that everything is built and we've got 4 tests running and they're all passing. The goal is to have them continue to pass as we make these changes. So on the left hand side, we see here, there we go, there we go. So we're going to need to pound include UnicodeString.hpp. And now this will no longer be a standard string. Oops. It's going to be a Unicode string. All right. Now, that one change we've got issues. I'm just going to go up to the top and start solving them one at a time. And the first one is actually the one that I expected. And oh, no. It had an error similar to this further down, but with an equal. So the left and equal. Oh, there's a plus that we need to add. Yeah, there's the double equal. And we don't have a way of converting our Unicode string into a string. So these are all the things that we need to add. All right, so let's I think it's buffer 3. Okay, so we're just going to start writing them. So first of all, we know that we're going to need a Boolean that is operator double equal, and it's going to have a const Unicode string ampersand called RHS, and it's going to be a const. Yes. We know that we're also going to need one for the less than, and we're also, this one will not be, this will be a Unicode string and this is operator plus. And then the last one, what did we say it was? Oh, to convert it to a string. How can we do that? Let's do operator string. Can I do it that way? I think so. Const. Okay. We also, the whole point is trying to get it to compile and then tell me, I mean, if I get everything stubbed out in my .hpp file, then it'll just say, hey, now I can't find these. So we need to also have, let's see, a size t length const. All right. So now it's saying, yeah, I can't find these, but it is compiling. That means if I add these and get them all working, then all of my code should work. So I'm just going to yank these 5 and now go into the .cpp file and there we go. So this will just put them back. And now I need Unicode string. There we go. All right, and now let's just get something compiling and break all of our tests. So we'll say that the length is always 0. this is going to be return an empty string operator plus return an empty string operator less than return false. Return false. There we go. Oh, unused. Do I want to do that? You know what? Let's just start. I don't want to have to do the maybe unused thing. So this is going to be return this arrow val is double equal to RHS arrow val. This arrow val is equal to, not double equal, but less than RHS arrow val. And operator plus, we will return this arrow val plus RHS arrow val. And since we have a constructor, this will, adding together two strings will return a string, and we have a constructor that takes a string, so it should implicitly convert that into a Unicode string. So we hope. And let's see. So converting it to a string, return this arrow val and this val dot length. Oh, all the right-hand sides are not pointers. So that should be a period. Is it not called val? src, source. Oops, sorry. So in the entire file, because I would just look for the for val, and it only occurs in these I just wrote, I need to substitute val for src. That was good. Okay. I mean, that's the conversion. So you say, Corey, does that mean we're done? Well, that's what I had planned for today, and I actually thought it was going to take longer. So let's try something else, something I've not done before, and that is the spaceship operator. And new in C++ 20. And return type of the operator function must be auto or 3 comparison category types. What are they? Strong ordering, weak ordering, and partial ordering. So now my question is for a C++ string. I can make this a little larger. Evidently my internet died. That was weird. What I want to see is the operator we go. The spaceship operator here. Oh my goodness. There. Number 14. So what I'm wondering is if we can replace this less than and double equal with the by just declaring a spaceship operator and passing that through to the strings spaceship operator. But what I'm just not sure if it needs to be the the return type of that is strong ordering. So that's what we're going to return, strong ordering. And the question is where? Is it just in string? Perhaps so. All right, let's do this. So now strong ordering. And what this the spaceship operator does is it allows the it's saying these can't be declared now since anyway. It allows the less than or equal to, greater than or equal to, all of those. It allows them to be automatically created, synthesized. I don't know if that's the right word, but in my mind, that's what's happening. It is creating them based on this spaceship operator. And the spaceship operator is, because of its shape, it looks like a spaceship, evidently, to some people. And what it does is it just returns less than 0 if something is less than. It returns 0 if it's equal than, or greater than 0 if it's greater than. It's a very well-known scheme, of course, in programming. So strong ordering, spaceship, and now should be able to just pass that through. Does that work? We're about to find out. Undefined reference to the maybe I didn't save it, that's the thing. I have not tried this before, by the way. I'm not, remember, I'm out of practice, about 20 years out of practice on C++, on anything beyond, just the basic stuff, and was never officially taught modern C++. So, you pick it up as you go, I suppose. And all right, this is better. Why is it better? Because I have error codes. I mean, I have compile stuff. So it doesn't know how to do string, Unicode string, Unicode string. As we go, okay. Oh, for operator equal for a string and a char. Okay. Is that the next one as well? Now this is a Unicode string, Unicode string. So we're going to have to look it up. I'm sorry, that was very anticlimactic. There, it's back. All right, so we'll just leave it at this, and let's start to put our documentation. So this is going to return true if the two Unicode are equal. Param RHS and then this right here should probably be something more like there we go. Yes. I'm going to fix all of the wording. So this is compared to Unicode strings. The string to compare against. Return true if the RHS string is greater than or equal to the object string. Sure. That works. This is going to combine two Unicode strings. The string to append. I'll use that word. It sounds fancy. The string to append to the current object string, and then instead of combine, we will say append one Unicode string to another. And what does it return? concatenation. Concatenate one Unicode string onto another. No, I don't like this. Create a new string, a new Unicode string that is the concatenation of one Unicode string onto another. How about we just say 2 Unicode strings there. Cast the current Unicode string object to a std string. All right. Returns the and I think I'm going to put here UTF-8 encoded. Because it is. We store everything in UTF-8. Compare to UnicodeString. Nope. This is going to be return the length of the Unicode string in graphemes. So we need to change this. It's a good thing we haven't ended yet. So returns note, this is not the number of bytes or bytes, chars, or code points. But is the length in graphemes as defined by ICU. Okay. So, why do we need to do this? Well, for the length, we can't just do this. We need to auto offsets is equal to get grapheme offsets of uString, not uString. ICU Unicode string from UTF-8. This dot source. Okay. And now, what do we return? We return offsets dot size. Is that right? Is that going to break something? Yes, it does. Question is why? And I think it's because let's look at these tests. It is in, no, this is in Unicode test. Okay. 514. This one right here. Oh, so this is in the equality test where it, I think it checks for the length first. Oh, I know. Well, okay, I know why, but this is not what should have happened. Well, so I said dot size, but remember size is actually 1 greater than, so it needs to be size minus 1. This should fix the tests, but it's not what I want. It's not fixing the way I want it to be fixed. So everything is happening, but the problem is now when we check the equality, the first thing it's going to do is, and I can just show you this. I can show you, this is in the, do I already have this open? ComputedExpressionString, that's fine. Let's go to 2. And when we so when I'm asking for val length, the problem is that's going to call get graphemes, and that's going to process the entire string just to know whether or not there's stuff there. So what we're going to do is we need to add a function that I can just ask for the byte length. And in order to do that, we can go to buffer 3. So we've got byte length. And now we're going to have a new one. There we go. So return the length of the Unicode string in bytes. Note, this is not the number of code points or graphemes, but is the actual number of bytes in memory. So we're going to call this bytes length. In bytes. Okay, so now we need bytes length. And so here's length. Now we're going to add our bytes length. And then that's just return this arrow source, which is a string, and we can ask for its length. Let it compile. All right. And now in our, I think it's buffer 2, where do we ask for the length? Right here is equal to true or false. We can use the bytes length, which bypasses the whole get graphemes thing. Is that the only one? Oh, okay. The not uses it. Anyone else? When converting it to a Boolean. Bytes length. Is there another one? Nope. All right. Small refactor that just is better for performance. Everything's still passing. Okay. That's simple enough. Is there anything else? The only other thing that we could do, I don't think we need to. What I was going to say is on the is equal, we could check the bytes length, but I believe it's going to do that anyway when we use the double equal check because it just passes through. So yeah, that should be fine. Having said all of that, let's look at our differences. Got UnicodeString. There we go. Got our operator. Our new functions. Using bytes length instead of length. And then our new functions in UnicodeString. Yeah. Let's do one last thing, and that's going to be in the includes of Tang. And are there any to-dos that we can take out associated with this? Oh, so Tang string. ICU is compiling in. Yay. Graphemes and string length. We have that. We don't have substrings. Wait, do we? We do have substrings. Yeah. We don't have HTML % encoding or % decoding. Computed expression string to use Tang string. We've got that. Don't have any of this stuff. In other words, there's more work to do, but that's good. Okay. Once again, wait. Instead of standard string. That's fine. 83 insertions, 8 deletions. And making our documentation. Only get stuff in docs, okay. What episode are we on? Episode 46. Episode 46, there we go. and it is pushed. And usually like to end with just looking at the lines of code, see how we're doing, and or the work that we put in. But yeah, that is good. And of course, the last thing we can do is just make sure everything compiles. But we haven't messed with the opcode, so everything should compile just fine. We could change our makefile so that it compiles with more cores. Right now, it's only using one. I could throw more at it, but I just haven't yet. And everything's working. So, you know what? This is a good thing. This is less than 45 minutes, and we have converted everything so that it's now using our ICU based strings. So, and what we're doing is, of course, we're storing the strings in a UTF format, UTF-8, sorry, got to say that correctly, UTF-8 format internally, and then we pass off to Unicode, to ICU when we need to do something like get the length or get the graphemes. And this is going to grow into just adding more and more functionality to what we've been working on. And we'll get HTML encoding, which that's the point of this, is that it's supposed to be a templating language, and so we want to be able to output templates of some kind, which means we properly escape things that need to be escaped. So HTML escaping, or a percent encoding is another one that we want. Why? Because you may have to output something to a URL, in which case you need to be able to do proper escaping for that as well. So yeah, that's coming. But as of this point, I think we're at a good stopping place. Thank you for joining me, and as usual, have a great day.